Now, the last crucial concept I want to cover here is related to reference versus primitive values. And what do I mean by that? Well, if we got a string, like user message here, that's a primitive value. Strings, numbers, booleans are all primitives. What's special about primitives in JavaScript is that we can't edit them. I can of course overwrite user message and store hello there, but that's a brand new string. The old string, which was stored in memory, will simply be thrown away. It's not edited to be this string. Even if I execute a method on user message, because just like arrays, strings do come with methods you can call on them, and I, for example, concat another string by using the concat method, this will produce a new string instead of editing the old string. So when dealing with strings and numbers and booleans, you always produce new values. You can't edit existing values. This changes when you're dealing with objects and arrays, which technically, as mentioned before, are objects. If I have a hobbies array here, with sports and cooking, let's say, and I then use, for example, the push method, which is a built-in method, to also add working to that array, I edited the original array. If I console log hobbies here, I get this new array, which contains working as a third item. Because push indeed edited the original array, it mutated the original array. Because arrays are objects, and objects in JavaScript are so-called reference values. Which in the end, to simplify it a bit, simply means that in a variable you don't store the value, but instead the address of that value in memory. So that array is stored somewhere in memory, so in the memory of your computer, and it's the address of that place in memory that's stored in this constant. When you then call push, for example, JavaScript will reach out to that address, open the value in that address, so take a look at that array in this case, and add this new item to this existing array in memory. So the array in memory changes, the address does not. With primitive values, like this string here, you could instead say that the string itself is stored in the variable. This is technically not 100% correct, but you can think of it like this. So you don't have this address thing here. This instead only matters when you're dealing with objects. There it's this address that's being stored. And that's also the reason why I can edit this array despite using const here. Const means that the value can't be edited, right? And still I can do it here. Well, because const technically does not mean that the value can't be edited, but that the variable can't be overwritten. So when using const, I can't use the equal sign operator to assign a new value. That won't work. If I save this, I'm getting an error. But I can absolutely store objects in a constant and then take advantage of the fact that those objects are accessed by reference, by address, to manipulate those values in memory by using that address. And I'm just mentioning this here because it can sometimes be confusing that I can edit an array, for example with push, despite that array being stored in a constant. Well, as I just explained, I can do that because I'm storing the address in this constant, and the address doesn't change, so I'm not violating this idea of having a constant variable which is not overwritten. But I'm instead editing the value that is behind that address. And that in turn absolutely is allowed.